Alright everybody, this is the Mac Daddy of all our substitution and elimination videos. This is really the ultimate goal for recognizing types of reactions from our Chapter 7 substitution and Chapter 8 elimination material. If you can do this, you're golden. You've assimilated everything you need to assimilate and you are in a great shape in terms of being able to figure out any combination of alkyl halides and substrates. So hopefully you have a good grasp of Sn1 Sn2 E1 and E2 reactions. Hopefully, because you need it to be able to understand this. What we're going to do is we're going to run through this in terms of tertiary substrates. We're going to then do primary substrates, and then we're going to do secondary substrates. So we're going to do each in turn. One thing to remember is that you will never have any of these reactions with more than two mechanisms occurring at once. Either Sn1 and E1 will occur together, Sn2 and E2 will occur together, or E2 or Sn2 will occur separately. You'll never see Sn1 happening by itself, you'll never see E1 happening by itself, and you'll never see a combination of three or all four mechanisms happening at once. So it's totally up to you to predict based on the substrate and the nucleophile or base. We don't really need to worry about the solvent too much. Substrate and nucleophile or base will tell you everything you need to know. Okay? Alright, well let's get to it. We're going to start off with tertiary substrates. Alright? So let's take a look here. This is a tertiary substrate. I have purposefully omitted any stereochemistry from all of these just to make answering our questions easier. We have a tertiary substrate, and we have a strong nucleophile and a strong base. Okay? So if you can figure this out, this substrate will tell you I can't have any Sn1 or E1 reaction because both of those only occur with weak nucleophiles and bases. Therefore, I'm limited to Sn2 or E2 or both. This doesn't tell us. The substrate, however, will. It's a tertiary substrate, which means it's going to have an alkene that is tri-substituted, therefore particularly stable. And for that reason, E2 is the mechanism that we see. So let's draw out the product. I got 6 carbons here, I got 6 carbons here. I know I'm losing my chlorine in the process. If this is my alpha carbon, and we've been through this several times if you watch the other videos about this, the hydrogen is going to get removed from one of these 2 carbons, and in this case it's going to be beta 2, because it's going to give a tri-substituted alkene. That is the reaction product from this reaction. Only one A2 reaction product. Now what about if we have exactly the same thing, a tertiary alkyl halide, but with a weak nucleophile and weak base? Well, when we look at what's going on here with a tertiary substrate, either the nucleophile or base is strong enough to come in before the leaving group leaves or at the same time, or the leaving group comes off first. This is a weak nucleophile and weak base, therefore the leaving group comes off first, leaving the carbocation. And because of that, because this is this is equally poor nucleophile and base, there's no preference for either mechanism predominating over the other, therefore both occur. In other words, we see a product of either E1 or Sn1 reactions, and we know that because of the fact we have the weak nucleophile and weak base. So I'm going to do E1, Sn1 over here. The E1 product is actually going to be the same as this E2 product because this beta 2 carbon is more substituted than the beta 1. So there's our elimination product. And so I'm going to draw out the substitution product after deprotonation. So hopefully you can see that the product we would get would be this. Again, no stereochemistry because there was none shown in the product. So here It's the nucleophile and base that is the difference, because in each case the substrate's exactly the same. All right. So that is what happens in a case of a tertiary substrate. Now let's look at primary. We're going to do exactly the same thing. Primary substrates will only react via Sn2 or E2 reactions. We'll find there is no possibility of E1 or Sn1. So we don't have any molecules like CH3OH, weak nucleophiles and weak bases. Let's look at this guy first. We have a primary substrate, which you know from what you've seen before favors Sn2 and does not favor E2 because it's only give a mono-substituted alkene. The nucleophile here is a strong nucleophile and a strong base because it's small and negatively charged. If the substrate favors Sn2 and the nucleophile and base favors E2 or Sn2, then it makes sense that we go with the one that's done twice, so therefore Sn2, and that's exactly what we see. The product here is Sn2. And that's it. No elimination here. No elimination because if we did have it, the alkene product would be mono-substituted, which is the least stable of all the alkenes, so therefore that doesn't happen. So no elimination. When we come down to here, the biggest issue you're going to have is remembering, well, what's this? Now the actual structure doesn't matter, but what matters is the fact it's a non-nucleophilic base. In other words, it's a weak nucleophile and a strong base. Meaning there can't be any Sn2 reaction. If there's no Sn2, then the only other mechanism is E2. All right? And that is exactly what happens. All right? Although the alkene that we get is not stable, it's the only product because this guy is too much of a big nucleophile to act as it's too big to act as a good nucleophile. Therefore, it only acts as a base. All right. So therefore, we only see elimination by an E2 mechanism. Okay. So the tertiary and primary are the simple ones. The secondary substrates are, of course, the ones where it's a bit more involved. All right. So this is why we've got three options here. So we have a secondary substrate first with something that's a strong base and a strong nucleophile. We also have here something that's a secondary substrate with a weak base and a weak nucleophile. And then we have something last that's what we just saw before, that's a weak nucleophile but a strong base. All right? So let's look at the top one. Secondary is in the middle of primary and tertiary. It doesn't tell us anything about whether we see E2 or Sn2. We know it's going to be E2 or Sn2 because we have a strong nucleophile and base here. This strong nucleophile and base also suggests E2 or Sn2. It doesn't suggest one predominating, and so for that reason, when you have a secondary substrate and a strong nucleophile and base, you get both elimination and substitution mechanisms. You get both of those occurring. So for the elimination, as is always the case, we follow the Zaitsev rule and get the most stable alkene product we can. For the Sn2 product, the leaving group leaves and we get the substitution and we get the nucleophile coming in. Again, there's no stereochemistry shown in the starting material, so I'm not showing any in the product. If I did have stereochemistry here, of course I'd have the opposite stereochemistry in the product. So two products, two separate products when you have a secondary substrate and a strong base and strong nucleophile. So when we have the situation here, the big difference is the nucleophile, right? It's a weak base and weak nucleophile, which suggests E1 or Sn1. Now, secondary substrate also doesn't suggest either of those, so both of these guys don't suggest E1 or Sn1. And therefore, just as up here, we have both mechanisms occurring. It turns out that the products will be exactly the same as up here, because the substrate's exactly the same. The difference simply is the mechanism by which they are occurring. So this is the Sn1 product, this is the E1 product. The Sn1 product I showed, as I always do, the deprotonated, the product after deprotonation. So these are the products right here. So what about the last situation, where we have a secondary substrate and a strong base but weak nucleophile? Well, hopefully you can see that that removes any possibility of substitution. If it's a strong base, that means we're going to have E2 or Sn2, but wait, we can't have Sn2 because it's a weak nucleophile, which means E2 is the only mechanism that occurs, and therefore we've already seen what the E2 mechanism product looks like, and it's there. So the point is that you can go through and use the combination of your your nucleophile and base and your substrate to easily predict whether you get one product or a mixture of two. And notice E2 can occur by itself. E1 and Sn1 only ever occur together, just as E2 and Sn2 can occur together. E2 can also occur by itself, just as Sn2 can occur by itself. But the point is that you only ever see E1 and Sn1 occurring together. And that's it. That's how you can predict whether your reaction occurs by Sn1, Sn2, E1 or E2, or a combination of two of those. And that's it.